So while factoring, it has many uses in algebra. One of its main purposes is to help us solve a quadratic. To solve a quadratic means that we're finding the values of x that make the whole equation equal to 0. We've actually done this before, and there's a specific name for those. These values are more than just solutions. So let's look at an example to see what solving quadratic gives us. We're given two equations, y equals 0 and y equals x squared plus 7x plus 10. I'd write that down. Okay, and basically anything I underline and or write down is what you should be adding into your notes. And we need to solve them. Okay, so if we're given two equations, this is a system, right? Our last unit was on system. We're given two equations, and we need to solve them, either using substitution or elimination. Well, since we have y equals in both cases, substitution is going to make the most sense. So what I'm going to do is I'm going to take what y equals is 0. I'm going to sub it in for that y in the other equation. So that brings us to 0 equals x squared plus 7x plus 10. Okay, so remember that with systems, we're looking for where these two lines intersect. Okay, so that's what this originally, when we're starting with these two, we're asking ourselves, where does the quadratic equation intersect with the line y equals 0? Well, y equals 0, that represents the x-axis, right? On the x-axis, every point has a y-coordinate that is 0. And y equals x squared plus 7x plus 10 is a quadratic equation in standard form. So we're looking for where the quadratic intersects with the x-axis. Names for that is x-intercepts. So really, when we are factoring a quadratic, we are finding the x-intercepts of that given graph. Okay, so let's add this part in right here to our notes, that most of the time the solutions to a quadratic equation are its x-intercepts. Okay, and I say most of the time because there are exceptions. We're going to talk about complex solutions when we come back from break. So that'd be something that's imaginary, and what that means for the graphs basically means that there aren't x-intercepts of those particular values. But we'll get to all of that. So one of the main things I want us to take away from today is that when solving a quadratic, we're letting y equal 0, and thus we're solving for its x-intercepts, or its x values that make y equal to 0. So let's work on solving the system, okay, by factoring. And so I look at the right side and I say, hey, that's a quadratic. And I'm wondering if there's a way to factor that. Well, I'm noticing that a is 1. So I can use one of the shortcuts for when a is 1, where the only thing I need to worry about is what multiplies to c and adds to b. Those numbers are 5 and 2. And so this factors to be x plus 5 times x plus 2. Okay, since a is 1, we don't need to use boxes. We don't need to use a factor by grouping method. And from here, this is where nothing has changed, right? All that I've done is factor the right side, and now we're setting it equal to 0. Okay, before, all the lessons we've done up to this point, there's been nothing to solve for. We're just simply factoring. So we just worked on what the right side had us doing. Now, how we solve this from here, we use what's called the zero product property to find our solution. And what the zero product property tells us, that if we have a times b equals 0, we either need a to equal 0 or b to equal 0, or a and b to both be 0. And here's why. If a equals 0, then we have 0 times b. Well, 0 times anything is just 0. If we have b to be 0, well, a times 0 is just 0. And if they're both 0, 0 times 0 is also 0. So basically what this is saying is we need each factor, or we need to find the value that makes each factor equal 0. So basically what I remember from this is after I factor, I take each one of those individual factors, so x plus 5 and x plus 2, and I set them each equal to 0. So x plus 5 equals 0, I would subtract 5, gives me x equals negative 5. I would subtract 2, and I get x equals negative 2. These are the solutions to this given quadratic. X equals negative 5, x equals negative 2. And again, these are x-intercepts. Okay, so just to explore this zero product property just a little bit further and kind of tie together what's happening here, let's plug each of these solutions back into the equation just to check our work. And I'm going to plug it into the factored equation. Okay, you can plug it into either one, but I want to plug it into the factor just so that we see the zero product property play out. So I'm going to plug in negative 5, so I get 0 equals negative 5 plus 5 times negative 5 plus 2. Well, by plugging in negative 5 to the first factor, that's what we found to be the solution from that factor. I get 0. And then negative 5 plus 2 is negative 3. Well, again, we don't care what that second number gives us, right? 0 times whatever we get there is still just 0. So I get 0 equals 0, confirming that negative 5 is a solution. And we could do the same thing for negative 2, right? If I plug that into this parenthesis, negative 2 plus 2 is 0. Negative 2 plus 5 is 3. 0 times 3 is 0. Okay, so all the zero product property tells us is when we have two factors, we need one of them to equal 0 or both of them to equal 0 so that they multiply together and ultimately get the left side to be 0. So this is why we factor, okay, or at least one of the reasons. So we can find its solutions, which represent x-intercepts, and it'll also allow us to find a bunch of other solutions where a quadratic might be involved. So real quick, I want you to solve each of these quadratics by factoring. So first factor, then use the zero product property to find its solutions. A hint is that you should always find two solutions. Sometimes it might be the same, but there should always be two solutions when factoring quadratics. All right, I'll give you like 3 minutes. Both of these should factor quickly. Number 1 has a shortcut. Number 2, use the hint that I keep giving you all when factoring. Maybe you remember what that hint is. I printed, you can keep that copy. I printed more than I needed to. So again, both those factorings should go quick. Number 1, the first thing I recognize is that A is 1. When A is 1, I know that I don't need to use a box or any formal method because it will always factor to whatever our numbers that add to B and multiply to C end up being. So in this case, 4 and 4. So I'm like, okay, since those are the same number, 4 and 4, this is a perfect square trinomial. And so both of my factors end up being the exact same, x plus 4, x plus 4. Again, that perfect square trinomial, that's just like a bonus for recognizing that. It doesn't make any difference whatsoever. So since both these factors are the same, when I go to solve them and set them each equal to 0, I get negative 4 and negative 4 again. Again, there's two solutions. It's just that negative 4 is a solution twice. So when we come back from break, one of the main things we're going to do is graph quadratics in different forms. When we get this solution of negative 4 to show up twice, that basically tells us that the low point of the quadratic, also known as its vertex, is. And any questions there about the factoring or the solution piece of it? All right, then for number 2. Again, my hints will always be to look for greatest common factors first. Okay, so if I look for greatest common factor in number 2, the x needs to get factored out. That has to happen, right? Both those terms on the left side have an x. So dividing both those terms by x, that's a common factor, and I get 2x plus 1 as the quotient or the result of dividing everything by x. Again, this is a quick check to make sure I've factored correctly by redistributing the x into the parentheses. Now, with this x, and this is why factoring out the x is so important, because one of our solutions comes from that given factor of x. So after I factor, if I take each individual factor, including x, and set it equal to 0, well, that's one of our solutions here. We do get 0, right? 2 times 0 squared plus 0 still equals 0. So 0 is a solution for this given quadratic. And then setting 2x plus 1 equal to 0, I subtract 1, divide by 2, and get negative 1/2. So graphically, I could at least get an idea as to where the graph crosses the x-axis and draw a rough sketch based on where these x-intercepts are. Okay, so that is it. That's why we factor.